Hello students, welcome to InstaOwl Chemistry Class. We believe in democratizing education for all. Today we are going to start with the chapter Acid, Bases and Salts. So let's begin with the class. Now, since we are talking about acid, bases and salts, we need to understand how we are going to identify whether a given substance is an acid or a base. For this, we require indicators. Well, what are indicators? Indicators are the substances that help us to identify whether the given substance is an acid or it is a base. So, we can have indicators. It could be natural, it could be synthetic. Natural indicators can be litmus, turmeric or red cabbage. And synthetic indicators could be phenolphthalein, methyl orange, methyl red. Now, how do they indicate us whether the substance is acid or a base? Well, they show us change in their color. So, they will show us different color in different substances. So, this is how indicators help us to identify. Over here in this slide, we can see the list of different indicators. You can see we can have over here different indicators and what is their original color and what color they show when they are added to acids or bases. For example, you can see red litmus. It is red originally. In acids, it shows no change in color, while in bases, this red litmus becomes blue. This way you can see this whole list for all the indicators. So let's take 2 minutes and read all of them. Blue litmus takes red color when it is added in acids, but there is no change when it is added to base. Next is turmeric, which is an natural indicators, which is yellow in color and becomes reddish brown in base while no change in acids. Then we have red cabbage, which is purple, but it becomes reddish when added to acids and becomes greenish yellow when added to base. Similarly, we can see in case of phenolphthalein, it is colorless in nature and it remains colorless in acids, but in bases it becomes pink. Next, you can see for methyl orange, which is orange initially, it becomes red in acids and yellow in bases. In case of onion and vanilla, originally we can see there is no particular color for them, but when they are added to acids, we see there is no change. But in case of bases, we observe that their smell vanishes. So this is how these indicators show us change in acids and bases. Now let's try and understand the very important topic, which is acids. So what are acids, how many types are present and how their properties vary. So talking about acids, they have sour taste, just like what tamarind has. And we have just discussed that the litmus color becomes red in case of acid. So if we are adding a red litmus, there will be no change, it will remain same. And if we are adding a blue litmus, it will become red. Next, we can see that acid solution conducts electricity. Why is that so? What is the reason behind it? We'll find out in coming slides. One more thing we can observe over here is that acids release H+ ions in aqueous solution. You must have already seen what is an aqueous solution in your previous class. So, talking about an aqueous solution, it is a solution in which water is the solvent. Such a solution is called as aqueous solution. So, in water, an acid releases H+ ions that you can see over here. Let's talk about some extra information. We have just talked about litmus and its changes. What exactly litmus is? So, litmus is a purple dye which is extracted from lichen, also called as thallophyta. Commonly, it is used as an indicator, which is going to indicate whether the given substance is an acid or a base. It is purple when neutral. Neutral means neither acidic nor basic. But when we add it to acid, it becomes red, and when it is added to base, it becomes blue. You can remember it simply by the word B, base B and blue B. So this way we can remember that litmus is blue in color when added to bases. Talking about natural indicators, then we have seen red cabbage leaves, turmeric, colored petals of flowers like hydrangea, petunia and geranium. So these are the some natural indicators. Now to each of these samples, what we are going to do, we'll put a drop of each solution on watch glass and test with a drop of indicators like red litmus, blue litmus, phenolphthalein and methyl orange. So we are going to use these indicators for all the previous samples mentioned. After that, of course, we are going to see some color change. So we will note our color changes in our notebook, and then we are going to predict and understand which one of them are acids and which one of them are bases based on our color observations. Now let's try to understand some more concepts through this activity. So in this activity, we'll be collecting solutions of hydrochloric acid. The chemical formula is HCl, then sulfuric acid H2SO4, nitric acid HNO3, acetic acid, sodium hydroxide which is a base, calcium hydroxide CaOH whole twice, potassium hydroxide KOH, we have magnesium hydroxide MgOH whole twice, and lastly ammonium hydroxide NH4OH. So now let's understand types of acids. So acids can be of different types based on the basis of differentiation that we are choosing. So over here we have divided on the basis of their occurrence, which means the source, how we are obtaining them. So acids could be natural acids or they can be mineral acids. When we say natural, that means we are obtaining them from natural sources. We also call them organic. So in this case, we'll be talking about acids which are obtained from plants, which are obtained from animals. So these can be methanoic acid, acetic acid, oxalic acid. Do you know where oxalic acid is found? Well, the seeds of tomato, it contains oxalic acid. Over here, you can see the formulas of the following acids. Moving to the next category, mineral acids. So you must have read this thing in geography about minerals, right? So we are talking about the same minerals. So where do you obtain minerals? Well, minerals are obtained from earth, right? The ground. So these mineral acids, they are obtained from minerals which are obtained from earth. Now some examples. So these are man-made acids, also called as synthetic acid, and they're also called as inorganic acids. Remember, the previous category was organic acids. Now talking about their examples, we have hydrochloric acid, we have sulfuric acid, we have nitric acid, carbonic acid and phosphoric acid. Along with this, we have many more examples which are related to minerals. Now let's discuss one more category of indicators. We have talked about natural indicators, synthetic indicators. Now we have olfactory indicators. What are olfactory indicators? Well, the previous indicators were helping us to understand acid or bases by the change in color. But this particular indicator will help us by change in the smell. So, substance that change odor in response to acidic or basic solution. So, there will be a change in smell. Either there was a smell initially and now there is no smell, or vice versa. So, some examples are onion, vanilla essence and clove oil. So what we are going to see, what we can see over here is these olfactory indicators are used in educational experiments to identify acidic and basic solutions. Also, they are useful for visually impaired people to detect pH changes through smell. So they can identify whether the given substance is acid or base because they cannot see color changes. So the change in smell, these olfactory indicators are a good help for visually impaired individuals. Now let's move to the second activity, which talks about olfactory indicators, which we have just discussed in previous slide. So over here we'll be doing onion cloth test preparation. For this, we are going to take chopped onions and clean cloth strips in a plastic bag. We'll tie tightly and leave it overnight in the fridge. Now next we are going to take 2 cloth strips and check their odor. Place strips on a clean surface, and to this strip we are going to add a few drops of dilute HCl. which is hydrochloric acid, and to one strip, and to the other strip we are going to add dilute NaOH, which is our sodium hydroxide. In the onion test, we can see that cloth strips soaked in onion juice lose their odor in basic solution, which is NaOH, but retain it in acidic solution HCl. So how we are going to understand? In HCl, the smell remains there, it retains. But in case of bases, the smell is not present. That means the strip which shows us absence of smell, that will help us to understand that it is a basic solution. So next is our vanilla and clove oil test. HCl and NaOH in separate test tubes, and once we add few drops of dilute vanilla essence, after that we can check their odor again. The vanilla essence loses its characteristic smell in a basic solution. If the smell is not present, the characteristic smell of vanilla essence is absent, then it is a base, and if it is still present, it will be an acid. And once we add few drops of clove oil, we can check their odor again. Talking about clove oil test, we can see that clove oil loses its characteristic smell in a basic solution. But in case of an acidic solution, it will retain. The smell will still be present. Now let's try to move to the next category of the chapter, where we will be discussing reactions of acids. So to understand reactions of acids, what we are trying to focus on, we will be understanding their chemical properties. So let's talk about chemical properties of acids. The first one is the reaction of acids with metal. So reaction of acid with a metal. When a metal reacts with acid, what do we get? We get a salt and we get a hydrogen gas as the product. Metal plus acid gives you salt and hydrogen gas. We can have one example of zinc. So when zinc plus H2SO4 occurs, we get zinc sulfate and hydrogen gas is released. Now over here we need to understand which all metals we are talking about and how do we confirm that hydrogen gas is released. So we'll try to get the answers of these two questions in coming slides. This shows another reaction where we have taken sodium with sulfuric acid. So when sodium combines with sulfuric acid, we get sodium sulfate, Na2SO4 and hydrogen gas. One more thing, we can represent gas with an upward arrow. Now let's move to the third experiment, which is our third activity over here. For this, we'll be taking 5 ml of dilute sulfuric acid, that is our H2SO4, to a test tube, and to it we are going to add few pieces of zinc granules to the test tube. Observe the surface of zinc granules and put a rubber cork on top of it. The gas which is released, we are going to pass this through soap solution. The moment the gas bubbles pass through soap solution, we'll get the soap bubbles coming out of it. Then what we are going to do, we'll bring a burning candle near the gas filled bubble. We are going to observe that there will be a pop sound. That pop sound is a characteristic test to identify that yes, hydrogen gas is released. So we can repeat this particular activity, this particular experiment with these acids also, like HCl, HNO3, acetic acid, and compare the observations. Now moving to the fourth activity. Over here we can see we require granulated zinc in a test tube, and to it we are going to add 2 ml of sodium hydroxide, that is base NaOH. To this, the next step will be to observe the reaction, what happens. So let's try to understand the reaction. When NaOH, that is aqueous sodium hydroxide solution, will combine with zinc granules, which is solid S, we will get sodium zincate, Na2ZnO2. It is very important formula, sodium zincate. Along with this, we are getting hydrogen gas. Now since we are getting hydrogen gas, so if we bring a burning candle close to it, the hydrogen gas will burn with a pop sound again. So hydrogen gas is formed. One more thing we need to see, that not all metals react this way. So we have seen that zinc is combining with base to give us salt and hydrogen gas. Not all metals combine with bases to give this reaction. Which are all those metals? Only zinc, aluminium. In case of zinc, we are going to get the sodium zincate. In case of aluminium, we'll get sodium aluminate. Now moving to activity 5. Label 2 test tubes as A and B, and to this add sodium carbonate about 0.5 gram. The formula is Na2CO3 to test tube A, and 0.5 gram of sodium hydrogen carbonate NaHCO3 to test tube B. Now to these two different test tubes, we are going to add 2 ml of dilute HCl to both of them, and then we are going to observe the reaction. Observe the reaction, pass the produced gas through lime water and record your observations. So what will happen when we are combining Na2CO3 or NaHCO3 with dilute HCl? We will observe that some gas is released. Now some gas is released, that means something is happening. You remember, we have done this in previous chapters, that when we see gas bubbles are coming or if we see gas is being released, there is some effervescence, then that means chemical reaction has occurred. Now since this chemical reaction has occurred, so we need to confirm which gas is this. So what we are going to do to confirm that, we are passing this gas through lime water. So in this setup you can see we have dilute hydrochloric acid, we have sodium carbonate to it. Once this reaction occurs, the gas is released. The gas is of course carbon dioxide. How we are going to confirm that? When this gas through this delivery tube goes to this test tube where we have calcium hydroxide solution. Calcium hydroxide solution is CaOH whole twice. This is our lime water. The moment carbon dioxide gas passes through CaOH whole twice, the lime water becomes milky. It will be milky in color. This milkiness shows that the gas passed is carbon dioxide. Hence, lime water turns milky is a characteristic test to identify carbon dioxide gas. Now let's see the reactions which we have discussed. So in test tube A, we are going to observe that sodium carbonate combines with HCl to give us salt, water and carbon dioxide. So since carbon dioxide is released, which can be confirmed using lime water turns milky. Another reaction test tube B shows where we have taken sodium bicarbonate NaHCO3. When it combines with HCl, again we are going to get NaCl plus H2O plus CO2. So again we are getting carbon dioxide gas. In both the cases, the carbon dioxide gas obtained can be confirmed using lime water turns milky. So how do we remember this, that carbon dioxide gas is released? You can see over here in the formula, since we are having carbonates and bicarbonates, so whenever we have metal carbonate or metal bicarbonate, they combine with acids to produce carbon dioxide gas always. So when we are doing this test, you need to understand this fact that initially lime water is colorless. When carbon dioxide gas passes through it, it becomes milky. When we add excess carbon dioxide gas to it, it will again become colorless. So we need to be very focused at this time. Now let's conclude our observations. Limestone, chalk and marble all are forms of calcium carbonate. Metal carbonates and hydrogen carbonates react with acids to give salt, carbon dioxide and water. Now let's try to sum up what we have done in today's class. We have talked about indicators, how they help us to identify acids and bases, how many types of indicators are there, natural, synthetic and olfactory indicators. Then we have also discussed acids and their types. Moving ahead, we have seen reactions of acids. We have seen their chemical reactions. With this, we have come to an end to today's class. I hope the session was interesting and you have learned so many new concepts about acids and indicators. See you in next InstaOwl Chemistry class. Thank you for watching today's session.